This is MAC 1105, section 1.5. And this section is all about solving quadratic equations. ax squared plus bx plus c equals 0 is a quadratic equation in general form, where a, b, and c are real numbers and a does not equal 0. If a equaled 0, you wouldn't have an x squared item and then it wouldn't be a quadratic. Quadratic means your highest power is x squared. All of these are examples of quadratic equations. There are going to be 4 methods for solving quadratic equations. And the first one we're going to look at is solve by factoring. And what's important about the solving by factoring is that everything must be on one side in descending order and equal to 0 before you factor. So this is in the right form, descending order on the left side equal to 0. This is just a matter of getting your 2 parentheses. This is x and x. Since the last sign is positive, the middle is negative. This is both minus 5 and 2. Now what this is talking about up here, the zero products principle, you should be familiar with. It says if a times b equals 0, then either a was 0 or b was 0. So if this is a product equal to 0, then either x minus 5 equals 0 or x minus 2 equals 0. And those are very easy to solve. You can just do that in your head. X equals 5. X equals 2, and those are our 2 solutions, and we solve that quadratic equation by factoring. You can check by putting 5 in for x, there and there, put 2 in for x, and they both work. So solving by factoring, the solving is very easy. What could be tricky is the factoring. It depends on your factoring skills. So everything needs to be on one side in descending order equal to 0. So I need to move the 4 over and set it equal to 0. Now this factoring is what we call the divide and slide is the way I teach this. So I'm going to come down here where I've got a little bit of room. What we do with divide and slide is we make up a new polynomial that will be easier to factor. And the way we do that is that we keep the x squared, we keep the 7x, we keep the minus, and we have a new last term that it comes from 2 times 4 is 8. And we're not going to put equal 0, because it's not equal to that equation. We are just making up a pretend polynomial to help us with the factoring. This polynomial in red is a whole lot easier to factor. Since the last sign is negative, one is plus, one is minus, and you're saying what multiplies to give you 8, that subtracts to give you 7, and it will be x plus 8, x minus 1. But that's just the factorization for this pretend red polynomial. Now we have to go back to something that is, we just dropped off this 2 when we created this 8 at the end. Since we multiplied by 2 to create this new polynomial, we have to go back and divide those numbers by 2. So 8 divided by 2 is 4, which gives me that parenthesis. And now here 1 doesn't divide by 2 evenly, so this is where we slide that number in front and it becomes that coefficient. So that method is called divide and slide. If you've never seen that before and you want to look at this playlist, there is a video in this playlist called Factoring Trinomials the Easy Way, and that explains this a little better. So now I'm going to take this factorization here that's in black and come up here and put x plus 4 times 2x minus 1. And of course there's other ways to factor a quadratic, and if you know those other methods, that's fine. This is just the way I teach it now. Now that we have it factored equal to 0, I can set the first one equal to 0. I can set the second one equal to 0. Subtract 4 from both sides gives me x equals negative 4. Here I need 2 steps, add 1 to both sides, divide by 2, and x is 1/2. And you can plug those in and check them. This third example I put in here just to remind you of a certain kind of factoring that seems like everybody forgets these days, and that is the only kind of factoring you can do here is take out the GCF. Factoring out the GCF should be the first kind of factoring you think about. So the GCF for this is 2x, and what's left inside here is 2x minus 1 equals 0. I'm ready for the zero products property. Set the 2x equal to 0. Set 2x minus 1 equal to 0 and solve them. Divide by 2, so x is 0. And add 1 to both sides and divide by 2, x is 1/2. Anytime you have a monomial GCF that contains a variable, automatically x equals 0 will be one of your solutions. So if I had 3x times x plus 7 equals 0, I know looking at this without doing any solving that I have to have 0 as one of my solutions. But that's only true if your GCF contains a variable. If your GCF is just a number, that is not true. Now that's the story on solving by factoring. Not everything factors. The next method we want to look at is taking the square root. The directions will say solve by taking the square root, or it'll say solve with the square root method. You only use this in certain circumstances, and it's this idea. You've got a squared term on one side, and you've got a number on the other. There is no plain old x term unless that x is inside parentheses that are being squared. We'll get to that example in a minute. So solving this by taking the square root is pretty logical, because if this is x squared equals 16, to undo x squared, we do the opposite, which is take the square root. And what you have to remember is anytime you solve by taking the square root, you have to remember a plus or minus. And that's it, plus or minus 4. Now, that was perfectly set up where we had the x squared on one side and the number on the other side, easy to take the square root. Here I have to do a little bit of working. I call this isolate. You'll hear that a lot in this class from me. You've got to isolate the squared before you take the square root. So add 15 to both sides. Still don't have the squared isolated. Divide both sides by 3. And now we have x squared equals 5. The x squared is isolated. Now it's time to take the square root of both sides. So that's x equals plus or minus the square root of 5. There's nothing we can do with that because it's not a perfect square. It does not factor tree out. Third example, similar in terms of I've got to get the x squared stuff on one side and the plain old number to the other. X squared is not yet isolated. Divide both sides by 9. So x squared equals negative 25/9. So here the x squared's all by itself. We're ready to take the square root of both sides. So this is x equals plus or minus. Now we've got some simplifying to do here. First off, remember the square root of a negative produces an I. Square root of 25 is 5. Square root of 9 is 3. Now that looks silly with the I in front. So this is actually plus or minus 5i over 3, or 5/3 I. Remember, when you take the square root of a negative, that's when you're going to get the imaginary number. Now these two have, you might look and go, wait a minute, there is an x, but that x is inside the parentheses being squared. If you FOILed that out, you would have x squared minus 4x plus 4, so there is an x squared here. This is pretty easy to do. Undo the squared by taking the square root of both sides. So this is x minus 2 equals plus or minus square root of 6. The x is not yet alone, so I need to add 2 to both sides, and be careful about that. You can't add 2 to the square root of 6 and call it the square root of 8. That 2 is a whole number. The plus or minus is in the middle, and then you have radical 6. There is a possibility at some point that this is not a perfect square, but that it is something that you could factor tree out. It just doesn't happen on these examples that I chose. So that's your solution. Now MathLab will ask you to type this in, but you'll have to do 2 plus radical 6. Then you'll have to do 2 minus radical 6. They don't let you use the plus or minus sign. Similar here, to get this alone, remember we must isolate. Divide both sides by 4. Gives us x minus 3, quantity squared equals 4. To undo the squared, we take the square root of both sides. Because we took the square root to solve, we have a plus or minus. The square root of 4 is 2. Now, I need to get this x alone and add 3 to both sides. Do not put the plus 3 right there where you think that your answer is plus or minus 5. That's not where it goes. Where it goes is like where it went over here. Put it in front of the plus or minus. Squeeze it in between. Think of it this way. Squeeze it in between the equal sign and the plus or minus. So I squeeze it in between the equal sign and the plus or minus. So simplifying this out, I have 3 plus or minus 2. I'm not finished with this. All the other ones had radicals or i's in them. This is plain old rational numbers. I need to do what I call high road and low road. The high road would be using the plus. That's why I call it the high road, going up 3 plus 2. And the low road would be using the minus, 3 minus 2. Arithmetic, 3 plus 2 is 5, 3 minus 2 is 1. So there are your two solutions. The only time you have to do high road and low road is if all you're left with are plain old rational numbers. These are integers in this case, which are rationals. In other words, if there is a square root, you can't do, like over here, if there's a square root, you can't do high road or low road. If there's an imaginary, you can't do high road or low road.